Hey class, welcome back to chapter 4, linear relationships. Our last exercise for the chapter is 4G, solving simultaneous linear equations algebraically. So in our previous exercise, we looked at solving simultaneous equations using a graphical method. So that involved plotting 2 points for each graph on a graph, connecting the dots and then seeing where the point of intersection was, and that was our solution. This time we're going to use algebraic methods, so there's no graphing involved. It is a little bit trickier just because it is algebraic, but I find it to be much quicker personally because you don't have to go through the whole process of drawing the graphs. So we'll jump straight in. There are 2 methods. I will demonstrate each of those. Okay, and I'll talk through that blue point on the screen as I go. So we're solving the following simultaneous equations using an appropriate method. Here we have x plus 2y equals 6 and y equals x take 3. So those are my 2 points. We are going to first use the substitution method, okay? This is really useful when one equation has one of the variables as a subject, because obviously we have 2 variables, okay? We can't just rearrange one to get a solution. We do need to do a few more steps. So the first step is going to be to label your equations, 1 and 2. I like to put circles around them. That just helps me remember which is which, and that way I don't confuse it with the rest of the numbers if they're in circles. So what you'll notice about equation 2 is that y is the subject of the second equation, okay? And we have y up here. So we have y equals x take 3 and x plus 2y equals 6. So what I'm actually going to do is literally substitute this whole bit here for this y here, because y is one and the same. Y equals x take 3. So I can write, and I write my steps to show my working, substitute 2 into 1. So I'm literally going to take this equation and substitute it into the top one. Okay. I'm going to highlight for a second. So I've literally taken that and replaced the y there with that. Okay. Now it's just a matter of solving as we would. So I have a linear equation in terms of just x. Ooh, I've lost my pen. And I'm going to expand the brackets first, so I get x plus 2x take 6 equals 6. Combining my like terms to get 3x take 6 equals 6. The opposite of take 6 is plus 6, so they'll cancel. And I'll do that to both sides to get 3x equals 12. And then to get x on its own, I of course need to divide by 3, and I'll do that to both sides. So this gives me x equals 4. That is half of my solution. I also need to find what y is. So now I'm going to sort of come up here. Using equation 2, because it's already in terms of y now equals x take 3, where x we know equals 4. Okay, so I'm going to substitute in the solution I've just found because it is all part of the same solution. Let me pick a different color highlighter. Let's go, that'll do. Okay, so this here has come from here. I've replaced the x in this equation. Okay, taking the pen, again, 4 take 3 equals 1. So my solution, and I use my 3 little dots to say therefore, 4, 1 is the solution. Okay, and that's our substitution method. So we literally take one of the equations and we substitute it into the other. All right, let's try another. This time using the elimination method. So the elimination method is useful when one variable has the same coefficient in both equations, or when we can make the coefficients the same. So what you'll see here next to B is that 6x plus 2y equals 6 and x plus y equals 7. Now, of course, we could really easily rearrange equation 2, and of course, I'm going to name them again, always label them 1 and 2. I don't mind if you swap them, but we could rearrange equation 2 so that it is in terms of y to get y equals 7 minus x, and of course, you're welcome to do that. I am, however, going to show you the elimination method. However, x here has a coefficient of 6, and here a coefficient of 1, and here y has a coefficient of 2 and a coefficient of 1 in the second equation. So we can make them both the same. I like to write 2 times, let's make the y's the same to cancel them out. So to give this equation here a coefficient of 2y, I need to multiply the whole equation by 2. And that gives me 2 times x is x, 2 times y is y, and 7 times 2 is 14. So I've literally multiplied this whole equation by 2 to get this equation here, which I'm going to call equation 3. Of course, it's the same as equation 2, just different coefficients. What we have now is these two terms here that have the same coefficient. So we can use the elimination method. They both have a plus in front of them, so we've got plus 2y and plus 2y. This is the tricky part, is deciding whether to add or subtract. Because they're both positive, we're going to subtract one from the other. If this was a negative 2y, I would 1 plus 2. Okay, so you want to cancel them out. So now what we get, and I'll use some more highlighter in a moment, I get 6x plus 2y, and that comes from the first equation. Okay, that comes from here. Oop, that should be a 3, sorry. Plus 3. We'll take 3, take equation 3. What color am I going to use? Green. And then I'm going to take this part, okay, and I'm going to subtract it. I keep trying to switch my pens, and I'm not too sure why. So now I'm going to subtract 2x, take 2y, don't forget to subtract both terms, okay, and that bit's there. Of course, you could look at it in terms of brackets. Actually, that might be easier to represent. All right, equals 6, take 14. So to finish highlighting those other bits, 6x plus 2y, that bit's here, so that's equation 1. And we've got the equals 6 over here. So note that they're both written first. You need to be careful of that when you're adding. And then the second term we are subtracting, so we've got minus, I've put the whole thing in brackets just to make things a little bit easier, and then minus 14, which of course came from here. Okay, so equation 3 I've underlined in green. And now we can expand as normal to calculate x. So really the substitution is only useful to calculate one of the variables, and then from there we'll just substitute. So 6x take 2x, we get 4x. 2y take 2y, this is where the elimination comes in. So they both cancel out. 2y take 2y is 0. 6 take 14 gives us negative 8. And then, of course, we'll divide both sides by 4 to get x on its own, to get x equals negative 2. Okay? Now we'll substitute that in. I'm going to substitute it into equation 2 just because y already has a coefficient of 1. And we get negative 2 plus y equals 7. Of course, to get y on its own, I need to add 2 to both sides. And therefore y has a solution of 9. Okay? So, and you can use so instead of the therefore. Negative 2, 9 is the solution. Now, of course, if you like the substitution method, and that's the only method that you can follow, which is fine because this is the easiest of the two, you could have rearranged this in terms of x or y. So you could have made it x equals 7 take y, or y equals 7 take x, and then substituted that in for whichever variable. You chose to put in front of the equal sign and then solve as per this, okay? Just make sure that you substitute in to find the second half of the solution here, okay? This is really important as well. Don't just say that x equals -2 and neglect to find y. That is part of the solution. As always, you may graph them to check as well. But those are the two methods. So there's, or you could add here as well if you needed to. I know it seems like a lot of confusion, but give it a shot for yourselves. The textbook has a lot of examples for each of these as well, has a fair few more than this. So have a read of those and see how they set it out, if my way doesn't make sense to you. And of course, you are welcome to highlight things as you go through and replace and substitute and add, subtract, whatever it might be, so that you can help see where things are going. As always, good luck with the work, guys. Always let me know if you have questions, and I'll see you all very soon.